Hi all, thank you for tuning into my channel, the Ozone Technology course. This session is session 15B. It will be the principles of application of ozone to liquids. In other words, what we will be doing is we will be concentrating more on how we apply ozone to the water in most of our treatments. Now, the session will incorporate the circulation or turnover, you call it, volume, recirculation, batch treatment, inline treatment, contact time, Venturi diffusion system. These are the subjects which I will be dealing in this session. It is important to know exactly how much water is being treated so that we should be able to calculate the amount of ozone that is required. The greater the volume of water, the more ozone we have to apply. Circulation, where the water is reused like in the swimming pools, the circulation time is applied. The circulation time is the number of times the total volume in the pool passes through the pump in the day. The circulating time can also be measured in hours as to how long it takes for the whole volume of the pool to complete one circulation. This is necessary because we want to make sure that the pool can be sufficiently chlorinated or treated in the amount of time. Now, turnover is the number of times the water in the cooling tower has concentrated and is measured in the number of cycles. This is determined from the TDS of the water being measured against the raw water. Turnover in terms of cycles equals to TDS of the water in the tank divided by the TDS of raw water in whole numbers. There are two processes available in an industrial application of the treatment of water using ozone. The one process is called the batch process and the other inline process. In the batch process, the production is made in batches of set volumes. For example, water can be treated in 10,000 liters or 1,000 liter batches. When one batch is completed, the second batch is processed and so on. This is usually applied in small commercial applications. In the inline process, the treatment is continuous and not in batches. This means raw water is continuously fed through the pipeline and ozone is applied within the flow of that water. The treatment will be completed by the time the water goes through the ozone system, the contactor, and will be ready for usage in the factory. Of course, in the interest of continuity, it is always possible that they might take the water and put them in a storage tanks, which will act as buffer. This slide represents a simple water treatment through the batch process for a small factory that is selling water or using the water for a small manufacturing concern. There can be either one big tank or two small tanks or two big tanks. Let us say each tank has got 10,000 liters or 100,000 liters, whichever the organization would want to have. The raw water goes into both of the tanks and gets filled up. When this tank is full, then this tank is ready, this water is ready for ozone treatment. In which case, the water is taken from the bottom and goes to the tank through the pump, through the venturi, and back into the tank as a circulation. As the water is circulating from here, up, back, and down, and when it passes through the venturi, ozone is fed. That way, this tank will be completely ozonized, and when the ozonation is complete, which can be confirmed from ORP or dissolved ozone meters reading, this will be taken through a pump, a secondary pump for the use in the factory. While this water is being consumed, this water gets treated and it circulates through the two-way valve, through the venturi and back, and ozone is fed through the venturi. So this tank gets treated while this tank gets used. So when the tank is depleted, the factory just simply connects and uses this water for their treatment, while raw water goes in and fills this up. This way they should be able to get a reasonably continuous supply of treated water for their factory purposes. This slide incorporates treatment of water with ozone using the online feed. The raw water goes in through the sand filter and is filtered, and as it is being filtered and goes to the contact chamber, ozone is fed through the venturi. A small portion of water is taken out of the filtered water through the ozone feed pump and goes through the venturi, and that water is ozonized and it joins up with the main supply of water. The ozone is fed through the compressed air line feed into the compressed air is fed through to the ozone generator, which will have an oxygen separator there, and the ozone gas comes out and feeds into the venturi. Here you notice there is no recirculation. So once the ozone is fed into the venturi and goes into the water circulation, it goes through the contact chamber. The contact chamber is purely designed to increase the contact time of the ozone gas that is within the water, so that as much of the ozone goes into the water, and once that the water passes through the contact chamber, and by the time it received here, most of the ozone will have sufficiently mixed with the water to get ozonized water. This ozonized water is collected through the storage tanks, and continuously, and is used up as it is needed from the two tanks. It goes back through another filter to remove any particulates and so on that has gathered here because of the ozone treatment, and after it passes through the sand filter, it goes straight to the processing plant. So if you notice that the raw water comes in, continuous movements, goes right up, back here, and goes straight out and back there. through the pump. So it is a continuous flow. Obviously, these storage tanks are just served as a buffer. You can also connect this line straight to the pump, which can be used directly to the processing plant. But generally, it is safer to use storage tanks as a buffer. This slide shows the design of a venturi. The venturi system is actually water coming under high pressure and expanding into the space, then causing some suction here. And the suction will suck ozone into the system in very fine atomized form and mix with the water to have an ozonized water. So in the online systems, the concentration of ozone must be high so that the total amount of ozone that is used for the whole water supply that goes will have sufficient ozone quantity to be able to ensure total sanitation. This venturi also actually is used to create fine oxygen bubbles in this area throughout, so that the surface area of the oxygen bubble will be high. The total surface area of all the oxygen bubbles will be very high, so that infusion of the ozone into the water is facilitated and increased. An alternate method of diffusing a gas into the water besides the venturi is by using the disc diffusers. A disc diffuser is actually made of sand and special glue, and the holes in the disc, which are very, very fine. So when ozone comes from one side of the disc, it is broken into fine bubbles, and that bubble is created in the water, increases the surface of the ozone exposure to the water, and facilitates a good flow of ozone into the system, and thereby increase the ozone levels in the water. These systems are used in pre-ozonation in sewer treatments, particularly in sewer treatment, and sometimes in aquariums, where they treat the water before they pump it into the tanks where the fish are kept. We can compare the parameters of water that is treated with chemicals and that of water treated with ozone. In terms of total bacteria and pathogens, chemicals will kill 99.99% with a standard treatment, whereas ozone will kill 100%. In terms of virus is not destroyed with normal chemical treatment. Virus is totally destroyed by ozone. Cysts, chemically treated water will not kill cysts. Some cysts can be killed with ozone, but others like Giardia can only be killed in combination of ozone and chlorine. Dissolved organics, unless the use of flocculation methods are used, they are not normally removed. even with flocculations, there would be some overload. All dissolved organics are removed by flocculation or oxidation when ozone is used. Light scattering. It is interesting to see that with water with treated chemicals, particularly in the swimming pool, the light will be scattered. In other words, when you shine a torch in the water, you could see the beam of light. But however, if you treat the water with ozone, there will be no light scattering simply because there is no colloidal solutions in the water as they are removed by flocculation or oxidation. And therefore, when you shine a torch in the swimming pool, you can only see the torch of the reflection on the floor and not the beam. Color, generally with chlorinated or chemical treatment, it would be clear in most cases, but with ozone, it will be clear in all cases. Shelf life, with chlorinated water, shelf life is very limited because the 0.01 bacteria that survives the treatment will regrow in the water once the chlorine is depleted, using the dissolved organics as food and eventually cause the staleness of the water. With ozone, the shelf life is unlimited, subject only to recontamination by exposure to the air, which will add bacteria. However, these bacteria will not multiply in that water because there is no food in the form of dissolved organics. Repeated contamination, of course, will provide the dead bacteria as food for regrowth. So, as you would see, there is distinct advantage between of ozone treated water with respect to chemically treated water. Thank you very much for having the patience to view and see this session. And we have come to the end of the session 15B. The next session, 16, will be the chemical treatment of potable water. If you are new to this session, please refer to sessions 1 and 2 on program details and sessions 3 to 15A. Please note, from the next session onwards, we will be treating mostly on the applications of ozone on various aspects. Thank you very much and have a good day.